What's going on, Algebra Bros? In this video, I'm going to show you how you can classify the types of zeros that you're going to get with a polynomial function's graph. So let's start with example part A. We got f of x equals x squared minus 3x minus 2. First and foremost, because this is a degree 2 polynomial function, the total number of zeros that this is going to have is 2. Now, looking at the graph, which was generated using the TI graphing calculator, you can see that there are two x-intercepts. So anytime your graph is crossing the x-axis, that x-intercept would correspond to a real zero. So because there are two x-intercepts on this polynomial function's graph, there are going to be two real zeros. So that would force there to be no non-real zeros. And the reason why we know that is because the total number of zeros that this polynomial function should have is 2. So if there are already two real zeros, there can't be any more zeros whatsoever. One thing that we can do to just kind of streamline this is to just take note that the total number of real zeros and non-real zeros should equal the degree of the polynomial function. So if we were to take 2 and add it to 0, we obviously get 2, which is the total number of zeros for this polynomial function. So adding these two numbers together should give us the degree of the polynomial function. So let's see if we can maybe put that into practice with example part B. Here we have another degree 2 polynomial function. So the total number of zeros is going to be 2. But you'll notice that there are no x-intercepts. So because there are no x-intercepts, there are going to be no real zeros. Well, if we know that the total number of real and non-real should add up to the total number of zeros, which is 2, then that would mean there are going to be two non-real zeros. So two of the zeros of this polynomial, or actually all the zeros for this polynomial function will have i's with them. And that's something I definitely encourage you to verify on your own. So you can set this equal to 0, maybe use a quadratic formula and solve for x. Got a couple more here. Next polynomial function is x cubed minus 5. The degree is 3, so there should be a total of 3 zeros. It appears as though this graph is crossing the x-axis, but only in one spot. So that would mean there is one real zero. So keeping in mind the total number of real and total number of non-real should equal the degree 3, that means there should be two non-real. One thing I want to point out is that all of your non-real numbers in these tables should be even, and that's always going to be the case because of conjugate pairs theorem. So remember, any zero that's non-real is going to have its conjugate as being another zero of the polynomial function. Alright, so with that said, let's look at our last example for the video here, example part D. That's a degree 4 polynomial function, so there should be 4 total zeros. Looks like the graph is crossing the x-axis in two spots. Each of those would represent real zeros, so there are two real zeros. And keeping in mind that the total number of real and non-real should add up to the degree, which is 4, then there are going to be two non-real zeros. And that's how you can use the graph of a polynomial function to classify not only the type, but number of zeros that you're going to get. Hopefully that helps out. Of course, if you have any questions, feel free to let me know. Otherwise, I will catch you in the next video, and thanks for watching.